Today we're going to look at adapter views, which are these view types that are able to display other views in their body by having those views be generated at runtime via an adapter. So we're going to look at some very basic adapter view types, as well as the pre-built adapter examples that exist in the SDK that we can use when we want to build those very basic types. And then we're going to look at how we can dynamically populate or modify the elements being displayed in an adapter view at runtime. So let's first do a quick recap so we have a clear understanding of why adapter views operate the way that they do. And what we have to appreciate is that in Android, everything that we see is a view. And as I've mentioned before, some things that we don't see, such as layouts, are also views. For example, if you see text in an Android application, there is a 99.9% chance that this text is being displayed to you via a text view. The only 0.001% of apps out there that display text without using a text view are those that might have a custom view where text is drawn on a canvas. So you might see that in some games, or maybe some sort of charting tool where dynamically drawing things on the screen is necessary. But in almost all instances, text is provided by a text view. This is essentially what adapter views exploit. They allow us to use text views in scenarios where we want to present a collection of text elements, or image views in a scenario where we want to display a collection of images, and it goes on and on. Essentially, what we can do is, via an adapter view, we can generate a collection of different views, either the same view type or different views if you really want to get into the weeds, and have those views be displayed, and this at runtime. And this allows us to do things like have scrolling lists of elements, again, whether those are simple text views or more complex composite views made up of a lot of different view elements. Now, these views that are displayed by the adapter views are created or generated by what we call an adapter. So the adapter is generally provided with a set of data, and it uses the information in that set to generate views dynamically for each element in the set. Once the views are generated, the adapter view tends to present them to the user for some type of selection action, but this is a common case, not the only case. So you can essentially use this mechanism in a lot of different ways depending on the adapter view that you're using. From a technical perspective, adapter views extend indirectly the view group class, which is invariably what allows them to contain other views. And we also therefore will expect to find a specific set of functions allowing us to investigate the types of views that can be found in the collection, that can be found inside the adapter view, and modify the children accordingly. Again, most times this is operated on, or this is performed by an adapter, but we do in fact have these exposed functions if necessary. And as I mentioned earlier, the views generated by the adapters can be very simple, in which case we can use predefined adapters prepackaged in the SDK, or if our views that we intend to display are more involved, we may be called upon to create custom adapters where we can get down to fine-grained detail about what our views should look like. Some examples of adapter views are what you may hear referred to as a drop-down list in other contexts. In Android, that view is called a spinner. And here you see an example of a spinner showing a list of elements. And what we need to appreciate here is that all of these text elements, home, work, other, and custom, are all text views. And it's important that we appreciate that we're looking at views, not just arbitrary text. These are not just attributes provided to the spinner. In fact, these are views being generated by an adapter. Grid view and list view are two view types that are now deprecated in recent versions of Android, but still present us at least the general idea behind how adapter views tend to be used, where a grid view can give you a set of predefined columns or modifiable columns, and then elements as they're generated will add new rows. And a list view gives elements in a horizontal flow. In a sense, you could think of a list view as a grid view with a single column. And in fact, these two operate the same. Now, these two views are actually deprecated because of, one could argue, misuse of these view types, or at least the adapters that would power these view types, where there was always a recommendation, a strong recommendation by Android that a certain type of pattern called a recycle pattern was to be implemented whenever you were building adapters for these views. Oftentimes, developers would ignore that recommendation. As a result, and because of the negative impact of ignoring those recommendations, Google deprecated these two view types and introduced another view called a recycler view, which requires view recycling, by way of introducing something called the handler pattern. So we'll get a video about recycler view later on. I just want to make it clear why the grid view and list view are no longer in use. However, we will see that the recycler view is able to actually mimic the grid view as well as the list view functionality. So once the views are provisioned in our layout, we can essentially populate an adapter view by simply creating an adapter, whether it's a simple adapter such as one of these, what we call an array adapter, which is useful if you just have a collection of elements for which a text value can be elicited. And then taking that adapter and handing it off to your adapter view. That is sufficient for the elements to be displayed in the adapter view. So what we're going to do here is essentially work on an example. We're going to start by simply creating an application that has first a spinner, which we're going to use as an element to give us a list. And we're going to use that list as a way to do some sort of selection action. In this case, what we want to do is have a list of colors, and we're going to be able to select from any of the colors in the list. I'm also going to use a view type called view. This is in fact the base view type, the base view class from which all other views extend. And a view is basically just a canvas with dimensions, height and width. What I'm going to do here is I am going to use this view's canvas as just a canvas. I'm going to essentially select a color from the spinner and then have that color be displayed as the background color of this view object. So I'm going to change the ID of my view object to canvas, representing the way that it's being used. Spinner is called spinner. I'll leave it as that for now. It's not the most imaginative, but it'll serve its purposes. So right now, this is our layout, and we're for the most part done here. What I'm going to do next is switch to my activity. And the first thing I'm going to need is access to my view elements. So I'm going to create a reference to my spinner. And this is going to be a spinner. So that'll give me access to my spinner. And then I will access my canvas. Again, I'm using the same variable names as the IDs I gave to the views. That is not a requirement, but you can see why it would actually make sense because it helps me keep track of which view is being referenced by which property. So this is a view. I'm sorry, that should be canvas. All right, the next thing I need is my collection of elements that I'm going to display. So I am going to create an array of color elements, and I'm going to call that array of color elements colors. And in Kotlin, there are a series of convenience functions that you can use to create various types of collections. So in the case of creating an array of what I will call colors, but what I actually am going to do is create an array of color strings. So I'm simply going to create an array of strings where those string values will be color names. So I will include blue, white, yellow, helps if you spell it correctly, red. I'm having a hard time coming up with color names. And I'm trying to keep these simple for reasons that I'll show you later on. Again, these are strings. I need to put them in quotation marks. Green and cyan. All right, so here are my colors. Next, we are going to create an adapter that we will use to generate the views that our spinner will display. And the adapter we're going to create is a simple pre-built adapter called an ArrayAdapter. So we're going to create an adapter, ArrayAdapter, and that ArrayAdapter will have a specific constructor invoked. That will be a constructor that takes first a reference to context. In this case, context is going to be a reference to the running activity, which is a context source. Context is necessary to have views be generated or inflated. So whenever an object intends to create a view, or if you are trying to create a view element yourself, you will have to provide it with context in order for the view to be created. Next, we're going to pass a reference to a layout. And in this scenario, we want to pass in a reference to a very specific layout. We want to pass in a layout that contains a text view with the ID text1. This is essentially a specific text view that the ArrayAdapter will look for. Now, you do not need to create this layout yourself. Rather, the SDK provides a collection of not just layouts, but other types of resources that you can use for specific types of generic actions in an Android application. So providing drop-down elements, for example, for a spinner is a common action. As such, Android provides a layout file that we can use for that purpose. To access that layout file, we are going to type android.r.layout. And here we're going to see a collection. You simply need to find one that matches your specific context or your specific use case. In our case, I see one from a list called simple drop-down item one line, which is pretty much what we are looking for. So that's going to give me a set of, well, each of those will be a text view, and as such, the ArrayAdapter will generate a set of text views for each of the elements in the collection. Speaking of collection, the last item we will pass to this ArrayAdapter's constructor is a reference to our colors array. And now that we've done that, we have an adapter. The last thing I need to do is give my adapter to my spinner by simply specifying that its adapter property should receive the adapter object I just created. And just so we can see the application running before I introduce the adapter, we have a spinner here with no elements. I'll now remove the comment, provision the adapter for my spinner, and now when my application loads again, I see that I have an item, blue, and if I extend the list, I see all of the color elements, white, yellow, red, gray, green, and cyan. So my spinner has been provided with a set of elements. In this case, they happen to be text views, but they could be anything. Provided with a set of views that it can display both in a drop-down mode and then in a selection mode. So this selection action is something that my adapter view is able to perform. So the next thing we want to do here is essentially implement the next feature of our spinner, which is the second feature of every view, which is responding to events. So we've shown that our spinner can display elements. It can draw itself by having an adapter generate a set of elements that it then displays. But what happens when the spinner has an item selected? Well, that's what we want to find out here. So the selection action that is performed by a spinner can trigger or will trigger a specific callback defined in an onItem selected callback object. So I can set my onItem selected listener a spinner can respond to an onItem selected event. That is the event that gets triggered when the user picks an item from the drop-down list. So in order to give my spinner an onItem selected listener, I simply initialize that property, and I will provide it with an onItem selected listener that I will create as an anonymous object. And I'm just start to type onItem selected listener, and I will create an anonymous object from the onItem selected listener interface that is defined in the adapter view class. We'll see that when I implement the members, there are two functions, onNothing selected and onItem selected. The one we're going to focus on is onItem selected. OnNothing selected is a callback that gets invoked in scenarios such as when the spinner elements are cleared, leaving nothing selected. You can have the spinner perform a certain action in that scenario. So we're going to leave that unimplemented, and we're going to come up to our onItem selected, and we're going to take a look at the parameters for our onItem selected callback. We see that the first item is an adapter view. That is essentially a reference to the spinner. As mentioned before, all of our event listeners will have as the first argument in each of the callback functions a reference to the object on which the callback is being invoked, the object on which the event was triggered. So this was going to be, in our case, the spinner object. P1, or the second argument, is the specific view that was selected from the spinner. Remember, our spinner is not just displaying arbitrary elements. In the case of text values, for example, it's not displaying the text, it's displaying text views. So if a specific view is selected, that's what will be returned here. The second item, or the P2, which is the third argument, is the index for the element. So the view itself, and then the index for that view, 0 being the first, all the way to n-1 for the last element. And then the final argument that will be passed into us, the parameter P3, is a long value representing the ID of an item, the item that is returned. This is oftentimes either not implemented, just not used, or it simply returns the same index value. And that is because this value is really only useful in scenarios where our spinner is displaying elements from some structured data collection, such as a relational database. In such a scenario, the ID for the record could be returned here because that value may have some use. But in a standard collection, say an array or an array list, the ID is not, if there was an ID in that case, it would be just as useful as the index. So the index is really what we tend to focus on. So what we can essentially do here is say whenever a particular item is selected, what we want to do is to display the color that was selected as the background color of our view. Recall that our activities layout had two elements, the spinner, which is where we are seeing our populated text views, and this view that I'm referring to as a canvas because it's going to show the color that we select. So what I'm going to do here is I am first going to extract the color value, i.e. I want the name of the color that was selected. Now there are a couple of ways to do this. One is the correct way, the other is incorrect. The first way is to essentially try to extract the value from the view object. So I'm going to do it. I'm going to show you that it works, and then we're going to talk about why you wouldn't want to do this. So in this scenario, I'll say that I have a string value, and I'll call it color name. I mean, I could just as easily call it color. Let's just do that. And my color value is going to get P1. P1 is view is currently nullable, so I need to essentially insist that it's here, or rewrite my code to say only execute if P1 has a value. So I could do that by saying P1 run, and then from here I could say val color is equal to this. P1 is now this, so I do not need to reference it directly. It is the context object. So I can simply say this particular view is a text view. As such, I would have to cast it as a view, as a text view. And then from that text view, once I import the class, that is, from that text view, I can extract the text value. And then I want to call to string on that to make sure that color is a string value. If I did not call to string, then I would have text, which would be a char sequence. So we want to make sure that we get the right data type. Now that I have the color value, I can essentially change the canvas's color by calling set background color to be. And what I'm going to do is I'm going to reference this class available to me in the Android SDK called color. And color has a function, parse color. Parse color takes a string, specifically the string which is the name of the color you would like to convert into its numerical representation. So I'll just pass in the color that is selected, that I've extracted from the view. I parse it to its numerical representation, and set background color accepts that numeric representation and will set the canvas color to be the selected color. So if I run this application as I have it here, what you will see is as soon as the application runs, I see that I have a color selected, blue. Notice I have not done a selection manually, but the application and the activity loads with this color already selected. So that is a feature of spinners, not a bug. Whenever a spinner loads, the very first item in its list is considered selected, and it will trigger the selection event, and therefore any on-item selected listener that is associated with the spinner will have its on-item selected function triggered. If that is not your intention, then you'll have to work around that. Yeah, and there are lots of different workarounds. You could make the first element in your spinner an instruction, for example, and then ignore index 0. There are more involved ways, not that I would recommend, but the easiest thing to keep in mind is that a spinner selects the first item in the list. So try to essentially factor that into your design. But as you can see, as I select additional items, they show up as selected. So this is essentially functional code, but it's broken in one important respect, and that is this. At this point, I have three objects sort of working in tandem. I have my spinner, I have my ArrayAdapter, and I have my on-item selected listener. The spinner is aware of the ArrayAdapter, it has a reference to it, and it is also aware of the on-item selected listener. It is aware as it has a reference to that as well. However, at this point in time, the ArrayAdapter and the on-item selected listener don't know about each other. And what we mean in that by that is neither object has a reference to the other. They don't know that the other exists. Each object is just doing its own job. The ArrayAdapter's job is to generate views. The on-item selected listener's job is to respond when an event in the spinner, when an item in the spinner is selected. The way we have written our code here, which is we take the text view that is returned or that is passed to us in on-item selected and extract the text value, is not respecting the fact that we don't know ArrayAdapter. What I mean by that is we are exploiting knowledge that I know as the developer, but that the object itself has no way of knowing. I am exploiting the fact that the ArrayAdapter is generating text views, that the adapter that the spinner is using is generating text views. But that doesn't have to be the case. In fact, I could get rid of this ArrayAdapter and use a different adapter type, one that generates images for each of the colors. In that scenario, the view that gets returned to me here would be, most likely, an image view. So the on-item selected listener would then be trying to cast that image view as a text view, which would throw a class cast exception, long before we even get to trying to access a text property, which wouldn't exist. Image views do not have a text property. So what we have done here is essentially increased the coupling between our on-item selected listener and our ArrayAdapter. And it's not even an explicit coupling where there is a reference to it, but it's an implicit coupling where I am using knowledge about the ArrayAdapter to influence the implementation of the on-item selected listener. in this scenario, if the adapter changed or generated a different type of view, I would have to go visit my Untitled selected listener and change its implementation to match. And that's not ideal. What we would like is for these elements to operate independently without any knowledge and with as little interaction as possible. So this brings us to the proper way to implement this feature, which is we do not want to access the view to figure out what item was selected, not unless we absolutely have to. And in this case, we don't have to, because we have something that is far more useful. We have the index of the item that is being used to generate the view. So in this case, what I'm basically going to rely on instead is the data model. So in the case where we're trying to limit coupling, one could appreciate that insofar as we can't write applications that don't know anything about the other components, no component knows anything about any other component, that's exceedingly difficult to accomplish. One could appreciate that at the very least, it's okay for an object to know about the type of data that it is operating on. So one could understand that because this Untitled selected listener needs to do something with the data that is returned, it must know the type. So it's fine for us to know that there is an array out there that is manipulating strings. And those strings can be then sent to us and we can then use it to change the color. I don't have to know about the ArrayAdapter, but I should know that there are strings out there. So what I'm going to do is I'm going to get the string value to use as my color rather than extracting the text property from the text view. So in this case, I am not going to use the view object that is passing as an argument. And before we even think about it, I'm actually not going to try to access the colors argument directly. I want to assume that this could have come from anywhere. Right now, sure, it's a property defined here, but it could just as easily have been pulled in from some other component and fed into my spinner some other way, or into an adapter. So I'm going to use the proper channels, which is I'm going to ask the spinner itself to give me the element that it possesses at a particular index. So that is a function that is exposed by the adapter view. So in this case, I'm going to say if the adapter view is not null, so if there is an adapter view, which there will be if it's attached to the spinner, my color is going to be get item at position, and then I'm going to pass in the index P2. Get item at position is going to return to me an any object. So at this point, it is not returning a specific type. It's just an any, which is similar to Java's object type. Basically, everything is an any. And this is where knowing about the application's data model is important, because at this point, this is where I can say, well, yes, get item at position, which is a function exposed by the adapter view, that is returning an any object. I know that in reality, that object is a string. So I can call toString on that object and get the name. Technically, you can call toString on anything because toString is defined for the any class. So it would work regardless. But in this case, I know it will give me exactly what I'm looking for. And now if I run my application, it will function exactly the same. But now I'm not concerned if someone were to change the implementation and use, say, a custom adapter instead of the ArrayAdapter, which my initial implementation was based on. So the last thing we're going to look at is populating our application and looking at how that can essentially impact the behavior of some of the components. So in this scenario, my application is built around an array, because that's what ArrayOf gives me. However, there are other components that I could use. For example, I could create an array list. And an array list in this scenario actually gives me, and I don't even need a generic reference here, this array list essentially functions the same. I can pass this array list to my ArrayAdapter, and my ArrayAdapter can then be assigned to my spinner. So at this point in time, my application functions exactly the same. The difference here is my array list now has the ability to be changed. Whereas an array has a fixed size once it's created and has a certain number of elements, that's it. The array cannot grow or shrink. An array list is dynamic, less efficient than an array, but far more flexible. So in this scenario, I could actually add to my list by simply adding an extra color. So what I'm going to do is hop over to my layout file, and I'm going to mess around with this a little bit, and I'm going to quickly add two views. I'm going to add an edit text, and I'm going to add a button. And here I am going to, again, another way to do this quickly is just to have the constraints inferred, but I find that if I do it manually, I have a little more control over what my final views look like. And this edit text, I'm going to call it color name edit text. And this button, I'm going to call add button. And I will change the text value of my button to read add. And just because I know name isn't something, I'll remove that text value. And I'll set a hint, enter a new color. So you may be able to tell right away what my intention is. What I would like to do is to allow the user to type in a new color name. And then by clicking the add button, we want to add it to the list of selectable colors. So that's our goal. So let's quickly write the necessary code for that. So in addition to wiring up my spinner and my canvas, I also need to wire up my, see, I've already forgotten the names of my views, but I will try to infer them without looking back. So my color edit text is equal to find view by ID. It is an edit text. I have to be explicit because at this point in time, Kotlin doesn't know the type of my property. I'm creating this value locally, and I have not specified a type. And then it is r.id.color name edit text. So that was the proper name of it, but I'll leave it so you can appreciate that the property name and the I shouldn't call it a property. It's a property when it belongs to the activity. So please excuse me. But the name and the ID of the view in the layout do not have to be the same. And then lastly, I will add my add button. Button r.id.add button. And then what I want to do here is relatively simple. After everything is said and done, I'll come down here and I'm going to give my add button an on-click listener. And the behavior I'm going to implement is this. I am going to add to my array list the item that the user types in to color edit text. I was trying to to evaluate it, but it's fine. I'll just do color edit text dot to string. There was no concatenation happening, so it did not elicit the to string for me. So it's fine. So this is what I'm doing to add an element. So right at this point, my item is dynamic. So if I run my application now, again, I see my list as it stands. Blue is the first, cyan is the last. I don't have the color orange, so let's fix that oversight. So I'll add orange. And what I'm going to notice is as I look at my list, orange is now one of the members of the list. I could also get maroon and brown. And if I then select if I select the old colors, they still work. That's great. But you see my list is dynamic. And I'm going to explain sort of what's happening here. But before I do that, let's select our new colors to see what happens. If I select brown, well, that wasn't good. Seems my application crashed. Let's try that again. So my original colors are here. I'm adding brown again. And I'm going to hit add, and then I'm going to select brown. All right. So my application keeps crashing. Well, why is that happening? Well, before I can even explain something about the application I've built, we've run into this problem where my app is crashing over and over again. So let's take this opportunity to do some debugging. Now, what we see here in my run window, I would also see something similar if I was in the logcat, is what we call a stack trace. And a stack trace is basically the list of function calls and error messages that were on the stack or that were executed at the time the error occurred, at the time the exception was thrown. And this is going to be invaluable for detecting and fixing errors. If we study this stack trace, what we'll see is that there are a lot of lines here telling me about different functions and different components that essentially are a part of the stack trace. However, these are not always going to be most useful to me, are not going to be very useful. The two things that will always be useful to me are, first, the line in my code that caused the exception. So that tends to show up as a blue link that you can click and view. So it'll jump to the specific line. And the next thing will be the specific exception and the message. So in this case, it's an illegal argument exception. That means you've passed a value to a function call that the function is not built to accept. And in this case, the message is actually pretty straightforward. Unknown color. So why do we get an unknown color exception on line 37 of my activity where I called set background color with the specific string of the color value in string form? Well, it turns out that the color class in Android that we're utilizing actually cannot parse every color by name. In fact, it's a rather short list. So if I look at the color class's documentation in the docs and I search for parse color, I can see that in reality, parse color only takes a handful of colors: red, blue, green, aqua, fuchsia for some reason, lime, teal, but no brown. So that's not one of the colors that I can parse by name. Now, I can parse brown, just not via its English name. I could use a RGB value or something else. So there are other ways I could get the color brown, just not by typing the name. So what I need to make sure here is that as I'm typing in values, the name that I type in is from this list. So I could add navy, even though I cannot add brown. So let's try adding navy to the list. So we'll see if there's any difference between navy and regular blue. So I'll add navy. And I check in my list, I see that navy is an option and I select it, and there, it's a little darker than blue. We can see that there is some difference. So we've fixed the error. We've been able to look at the stack trace for an error, for a crash, to try to debug the problem and fix it. But I do want to bring your attention to something that's happening here. And it's good because it's happening automatically, but it's important that you're aware of this because it may not always occur. So whenever I add a new item, whether it's a valid value or not, like brown, when I add this value, it shows up in my list automatically. My list is automatically updated. Now, keep in mind what I'm actually doing. I'm actually adding the element to my array list. That's where I'm adding the element. Now, essentially, what's happening is that my ArrayAdapter that is referencing the array list is monitoring the list for changes. And if it sees a change, it automatically notifies any views that are using the ArrayAdapter. So in this case, the spinner, which is using the ArrayAdapter, is going to be notified if any element in color changes. That is, an element is added, removed, or changed. This is a feature of ArrayAdapters. The reason I'm making this point is if you were to build, say, a custom adapter and you did not extend ArrayAdapter, and you'll see that we in our next video, we will actually build a custom adapter. If you did this on your own, if you built a custom adapter that extended ArrayAdapter, you would get that feature. But if you built a custom adapter that extended, say, base adapter, you'll see that in the next video, you will not get this automatic update happening for you. So you may find yourself adding elements to the list, updating your array list, but your views may not be notified. In that case, to address that issue, what you can do is call on your adapter directly, notify dataset changed. Whenever you have manually added an item, you can call notify dataset changed. In the event you are using an adapter type that does not automatically monitor and trigger the notifications for you. So an ArrayAdapter will do it for us, no problem, but other adapter types may not. So you'd want to double check the documentation and simply try to observe the behavior yourself to determine whether or not you need to go in and add the notify dataset changed line yourself whenever the list is updated, or if it's something that won't be necessary. All right, so in the next video, we're going to look at implementing a custom adapter.